A very good morning to everyone present over here. Myself, A. Jafar Sadiq Ali, Professor, Electrical and Electronics Department, working in Sri Muthukumar Institute of Technology, Chennai. As part of this IoT concept and application series, today I'm going to cover the next Unit 3, IoT protocols and enabling technologies. In this, we are going to see the IoT protocols that is currently mentioned in the first line IP V6, 6 low wide personal area network, MQTT, COAP. And the second line is denotes about the enabling technologies, RFID, wireless sensor network, big data analytics, cloud computing, and embedded systems. So in this video, we are going to only cover the first two only, IPv6 and 6 LOWPAN, 6 low wide band personal area network. So these are IoT protocols, IoT enabling technologies. We'll see one by one. So these are the glimpses of the unit 3 topics. IPv6, nothing but Internet Protocol version 6. It's a new version of the Internet address system over the IPv4, which is running out of addresses currently. The second one is 6 low WPA, means it's IPv6 only over low power wireless personal area network. Okay. Third one is MQTT, message queuing telemetry transport systems, which we'll see later. COAP, constraint application protocol, and technologies RFID technologies, which we know already, radio frequency identifications, and wireless sensor networks also we are going to see, and the big things like big data analytics, cloud computing, and embedded systems. All those things we will see one by one in this unit in the coming series lectures. So first and foremost is IPv6, Internet Protocol version 6. It was developed by the IETF, Internet Engineering Task Force, mainly to deal with the problem of IPv4 exhaustion, because the internet has been there around from 1980s onwards, started from the US and all over the world, and currently is massively used by them, and it has reached its at a maximum limit, and that's why we slowly move on to IP version 6 versions. IPv6 is a 128 bits address having an address space of 2 power 128, which is way bigger than the IPv4, because IPv4 is nothing but having only 32-bit address only, and it uses a decimal only, wherein our IPv6 is going to use the hexadecimal format, semicolon separated by the colon. So what is protocol? We all know that, okay, certain standards and rules has to be followed and to exchange the data without any loss of the data or cross over the data. So these rules are nothing but the IoT network protocols. So need for IPv6. The reason are related to slowness of the process due to some unnecessary processings, the need for new options. See, there's a need for avoiding unnecessary processings, the need for new options, the need for supporting some multimedia files, and desperately we need for more and more highly security. And above all the reasons, the first and foremost reasons is that the number of connected computers over the internet is increasing dramatically, exponentially, and that's why we go for from IPv6 to IPv6. The main reason is after the rose of quickly when the IoT came into picture after the 1980s. So roughly, if you see, IPv4 provides about 4.3 billion addresses, and when only humans, we initially we thought that we only humans are going to use these computers and the internet, that's the reason we that time when the internet was invented, it was only 4 billion what it maybe. That the reason that they go for with the IPv6 version, which comprises of 4 billion addresses. At the time, scientists were thought that it was more than enough, but as and when go the time and the technology evolves, the devices are going to act as a smart objects, and it, each one will have its own IP address. That's why billions of IP address needs to be added on. That is the only reason that we are going for from IPv4 to IPv6, which is going to provide 3.4 into 10 to the power of 38 addresses to us. So this is the main um, difference between these two. 32-bit is uses 32-bit, now it uses 128-bit. It was decimal, now it's hexadecimal. The IP address initially was 192 dot. Everything will start with the 192 dot something like that. Now it is totally different. And the security was optional. Now it is mandated. This is the most vital reason that we are going for a change from IPv6 to IPv4 to IPv6, apart from the number of devices connected. And broadcasting, yes, it is no. And again, the need continues in a more prescribed manner. Address space 4.3 billion addresses to 340 undecillion addresses, 3.4 into 10 to the power of 38. And mainly, if you see the 11th one is QoS support. Okay, quality of service support. It was limited, but now it is been flow label field improved. Okay, there was we'll see one by one later on. It was 1012 variations are there, and also the address types also. It's unicast, broadcast, multicast initially. Now the broadcast has been deprecated. It has only unicast as well as multicast and all any cast. So this is the thing why we go for IPv6. Generally, IPv4 older protocol, limited address space, widely used today. IPv6 for next generation protocol, huge address space, better security as well as efficiency. See the type of IPv6 address, first 3 bits, then 45 bits for global routing prefix. It's totally 48 bits, 3 plus 45, 48 bits for provider. Then 16 bits for subnet ID. Then again 48 plus 16 means 64. Then again another 64 bits is only exclusively for interface ID. That's for host purpose. So 64 plus 64 is 128 bytes. And this is what the rough calculation of about an interface, how many interfaces can be added per subnet. For see here in the down, you see for per one subnet 18 quintillion devices can be connected, means we have again 16 subnets are available. So you can imagine how many we have. Okay, 65,536 subnets. So 65,536 subnets into again 16 trillion means that much devices can be connected by the IPv6. Very huge device can be connected. So this is the explanation about this previous diagram. This is the advantages of IPv6 real-time data transmissions. IPv6 supports authentications. That has got security as mandatory. Then it performs encryption also, the faster processing at routers places. Then disadvantages, everything has its own disadvantages, like transition period, because widespread of use of already been used by IPv4 by all the people. And shifting from older version to new version will take a longer time. That's the most perceived disadvantage currently we have. And the communication barrier, no backward compatibility. So IPv6 cannot run on IPv4 capable custom computers. So conversion challenges also is available. Protocol isolations, IPv4 and IPv6 cannot communicate with each other directly. So these are the main disadvantages which we need to work on to overcome all these disadvantages. So the next and the protocol that we are going to see is 6 low wireless PAN personal area network. It's a version of IPv6 designed for low power wireless networks. It works specifically on wireless personal area network, like home network, like a CAN network is a PAN network, personal area network, which is a wireless one. So it works only on the wireless personal area network, but its works is a for low power devices only. It's a technology that allows IPv6 packets to be transmitted over IEEE 802.15.4 networks, which is like a Wi-Fi, Zigbee type low power devices networks. WPAN is a network where devices are connected wirelessly around a person's workspace. So 6 low PAN enables communication using the IPv6 protocol, which is known for being faster, more reliable, and offering many addresses. So 6 low PAN was created to improve how data is transmitted over network, but it mainly supports small devices with limited processing power. So even the smallest of the I2 devices can now be a part of the network because of this particular protocol. And the information can be transmitted to the outside world as well. For example, it is LED street lights also. This is the main architecture of this 6 low PAN architecture. Already we know the Zigbee network. Zigbee network, it consists of only one coordinator and routers and end devices. That's what has been given. This though all those things comprises of 6 low PAN. So many 6 low PAN networks can be connected to the internet, and it can be connected to the any IP enabled devices like computer, laptop, servers, whatever devices you are based on IP, it can make use of that protocols. So in this, we have, as we had discussed, we have nodes like a coordinator and a router and edge end devices. All these nodes will be with IPv addresses, uses IPv6 addresses, and it has one common edge router is available, which is through which IP enabled sensors are going to interact with the devices through the internet, that is cloud. So it mainly uses the AES 128 link layer security, which is highly having the encryption data in blocks of 128 bit length of each one. So this will give the full authentication as well as encryption facility. So this is most reliable and widely used for small low power devices. And this is the working architecture of Ellipsis low PAN. See to that in the bottom, if you see left hand side, 6 low PAN or network architecture, again that whatever the coordinator, host, and the end devices, All this consists of a collection of all these devices comes and connecting to each other, and all will be routed to one 6-low WPAN edge router. Through this edge router only, it has it can able to interact with the main routers, and the routers can be connected to another router or PC or the cloud system through the help of the internet. So this way, this is nothing but I just tell you with an example. Each node consists of, say, along our human being mind understand only if you give me a small real-time example. House means the small nodes, the coordinator or routers or end devices. And a 6-low pan means is small streets from the houses. And may a router and other things like means it's a main bus stop or main railway stations, something like that. So those things are directly not connected to the houses, it's connected to the help of this 6-low WPAN edge router only. So this enables the working of the devices very fast and secured manner. And it has got its own types, like three types: simple, ad hoc, extended. We'll see in pictorially what how it is been classified. Simple means it has a one edge router, and ad hoc means it has a collection of all the hosts as well as a router, but there's no connection has been made. It's be left alone. And extended low pan means it's again collection of all this edge router and host through more than one edge router. That's a nothing but the more than one simple low pan means nothing but extended low pan. So these are the different type of architecture of the 6-low WPAN protocols. And with this we have completed these two protocols. The rest of the things we will see later. And these are the reference books, textbooks, and references which I have referred it. Thank you for being with me.